Part 2 of Biometric Finger Vein Authentication System. To determine appropriate number of line tracking operations, comparison of finger vein pattern extracted was done using various number of line tracking operations. First, 16 finger vein patterns were extracted from a captured image, each image using the proposed method with n equal to 100. Next, all finger vein patterns were compared with each other in all combinations and the differences were plotted on graph. Finally, the procedure was repeatedly executed with an increased n, where n lies between 100 and 10,000. The figure A in the slide shows the relationship between the total number of line tracking operations, which is equal to n, and the differences among the finger vein patterns extracted from the same image. The mismatch ratio was small for larger n, which is greater than 3000, and it was about 0.5% only. This means that the patterns were approximately the same for all images. This step was followed by accuracy of the finger vein extraction. To determine whether the proposed method faithfully extracts the patterns of veins, we investigated the correlation between the patterns extracted with the proposed method and the actual patterns. The two-dimensional filter kernel is designed so that its profile matches the cross-sectional profile of a typical vein. An integer is selected for each value of a row element of the filter kernel such that the sum of the values in a given row is 0 and is shown in figure B. The matched filters consist of 4 different filter kernels with each filter rotated by 45 degrees to optimize for a different set of vein directions. In this experiment, we omitted spatial reduction and relabeling so that more accurate results were required using higher resolution images. The size of the data was thus with width 240 pixels, height 180 pixels, and moving distance CW equal to CH equal to 10, so that a displacement of the finger position by about 3 mm could be absorbed. The experiment was carried out as follows using the two images as shown in figure C. Figures A and B show the finger vein patterns extracted from the two images shown in figure C, respectively. Table 1 shows the results of matching. We can see that figures A and B that the proposed method led to little excessive extraction, while there was excessive extraction and many thin spots along the veins in images that created using the conventional method. These results show that the proposed method is better in terms of robustness against irregular shading and noise, and that it is capable of faithful feature extraction. Robust extraction of the finger vein pattern in shadowy images is important. We examined the proposed method's robustness against the irregular shading by using images acquired at different infrared LED light intensities and investigating the quality of patterns extracted from them. Figure C shows the brightest image. Figure D and E show the results of extraction from this image using the proposed and conventional methods respectively. Figure F shows the corresponding results for the darkest image. As shown in figure I, the image extracted using the proposed method was clearer than that extracted using conventional method. Figure I shows the relationship between the mismatch ratio and the image darkness. As captured image became darker, the mismatch ratio increased for both methods. The maximum value for the proposed method was 39%, 13% less than 52% obtained for conventional method. Our method is thus more robust against LED light intensity fluctuation. Now we shall see the demo of the same experiment. As can be seen, here is the program for demonstrating this experiment. Taking input image as finger.png, if we run the program, we get the output as can be seen here. So repeated line tracking method gives much more robust output, and matching score is 0.1717%. Coming back to the slides again, to test the performance of the design system for personal identification, an experiment was done using the procedure to identify large number of patterns. The experiment involved evaluating the false acceptance FAR and false rejection FRR error rates for a database of infrared images. The database contained 678 different infrared images of fingers with 2 images per finger. The FRR was obtained by calculating the mismatch ratios using both images of each finger, and the FRR was obtained by calculating the mismatch ratios among the images of different fingers for all combinations. The conventional method was independently evaluated in the same way. The relationship between the mismatch ratios and the frequency is shown in figure A. Each distribution was normalized by its maximum frequency. The averages of the distributions among different persons were high. The mismatch ratio was around 50% for both methods. The receiver operating characteristic ROC curve, which shows the relationship between FAR and FRR, is shown in figure B. It shows that EER was 0.145% for a mismatch ratio of 37.6% when the proposed method was used. The average time for feature extraction was 450 milliseconds and that for matching was 10 seconds. That is, the total time for identification was 460 milliseconds per finger. The response time was thus within 0.5 seconds. In other words, the response time sufficiently satisfied the requirements for user convenience in terms of response time. Finally, coming to summary and conclusion, a system for pattern identification technique on the basis of vein patterns of a person's finger was thus designed. For proper vein pattern extraction from unclear images, line tracking was done repeatedly with different starting points. Experimental results with equal error rate as 0.145% and response time as 460 milliseconds proved that this is a much more reliable and powerful system. This methodology of system design can be easily clubbed with other biometric identification methods like fingerprint. This system can be improved both in terms of the algorithm for greater recognition rate as well as the imaging device. Here we have the references. I would like to express my gratitude to Dr. Depengwu for his extremely good guidelines in creating interest in pattern recognition and matching area. The subject matter learned under his esteemed guidance is very useful to further delve into the depth of the subject, which triggers interest in the relevant research. Dr. Depengwu has constantly been the guiding force for us to be creative with the term project. He has extended his unlimited support during selection of the topic and through the completion. Thanks a lot.